All right, we're going to be looking at page 241, and this chapter is a lot about ratio and proportion. So we're going to take a look first off at what do these words mean. What is a ratio? What is a proportion? A ratio is a way to compare two values using a fraction or using division. When you say it makes a 3-to-2 ratio, when you use that type of wording, that means that you are working with 3, and you could write it as 3-to-2, like that, a fraction. You could write it as 3-to-2 using a colon, or you can write it as 3 and word 2, and then 2. What that means is one of the pieces is 3 parts compared to the other piece, which is only 2 parts. So you could talk about making cement, and you might have 3 parts of gravel, 2 parts of sand, and 1 part of Portland cement. And that makes a cement. And you can actually compare 3 values in that way then. What's that? Okay, I don't know the word you use. Okay, thank you. I didn't know that. So concrete then, 3-to-2-to-1. 3 parts gravel, 2 parts sand, 1 part cement. Okay, there's a lot of recipes for cement. This would just be, or concrete, this would just be one of them. Okay? Now, we do the same thing when we're working with recipes. I have a recipe I use that makes Munster cookies. I love them. Now, some people might not like them because they're really healthy. They have molasses and oats and raisins and walnuts and then spices like cinnamon and ginger. What's that? You like cookies? I might have to make them and bring them sometime. Okay? But what my cookies call for is 4 cups of flour, 4 cups of oats, 2 eggs, 1 cup of molasses, 1 cup of sugar, 1 cup of oil. Now, there's also cinnamon and ginger and so on and so forth. But when you look at this, the regular recipe actually calls for 8 cups of flour, 8 cups of oats, 4 eggs, 2 cups of... Now, this makes a huge batch. So what do? I divide my recipe in half. I never use the original. My bowl does not contain that much room for the original. I always use this half recipe. Okay? That helps us understand a little bit about ratios. Ratios can always be reduced. So for example, you want to make more cement than just 3 shovelfuls of gravel. Sorry, concrete. You want to make more concrete. than just 3 shovelfuls of gravel, 2 shovelfuls of sand, and 1 shovelful of the cement mix? Well, double it, or triple it, right? That's all you have to do. That's the way a ratio works. You multiply them all by the same number and you're still working with the same comparison. So we double this and we say, okay, well that's the same thing as 6 to 4 to 2. Okay? Now, whenever you're working with equal ratios, you are working with a proportion. A proportion is what happens when you state that 2 ratios are equal. So for example, when I say 3 to 2 is the same thing as 6 to 4, that is a proportion. Okay, we're going to be looking next section at properties of proportions. For right now, it's just enough to know what is a proportion. 2 equal ratios is a proportion. All right. Now, using ratios for this section, what are we going to be doing in the use of these ratios? Well, we know that we can reduce ratios, and we know that we can make them larger just by multiplying each of the values by the same number. If I have 3 angles in a triangle, 3 angles in a triangle, whose ratio is 3 to 2 to 1. So we have 3 angles in a triangle whose ratio is 3 to 2 to 1. What do we know about angles in a triangle? What do we know about the sum of angles in a triangle? They add to 180. So I know that these 3 angles have to add to 180. Are these angles going to have actual measure of 3 degrees, 2 degrees, and 1 degree then? No, that's what they reduce to. We've already reduced this ratio then. Let's say we reduced it by a factor of x, which means that this is actually 3x to 2x to x. Their actual measures are 3x, 2x, and x, and the sum is 180. So I write 3x plus 2x plus x equals 180. Dustin and Branson, are you paying enough attention to know what's happening up here? Okay, you need to. Now, when I add 3 plus 2 plus 1, that gives me 6x. So I divide by 6. X is 30. If x is 30, then what are the other 2 angles?
30.
Yeah, you multiply by 2 and then you multiply by 3. So this becomes 90. Those are the 3 angles in a triangle whose ratio is 3 to 2 to 1. Let's do another example, still using our definition of ratio that we worked with here and doing what you're going to be doing on your assignment. We have 2 complementary angles. These complementary angles have a ratio of 3 to 7. So we have complementary angles. With a ratio 3 to 7. Now, what do we know about complementary angles? What does that mean? They add to 90. So these angles sum is 90. Their actual values then cannot be 3 and 7. So 3 to 7 is reduced. Let's say it's reduced by a factor of x. Are you paying attention, Branson and Dustin?
Yeah.
Okay, because that'll be important because I'm teaching you how you do some of these problems on your assignment. So since it reduces to 3 to 7, let's say we reduced it by a factor of x. So the actual ratio is 3x to 7x. Which means when I add these actual numbers, I get 10x equals 90. So divide by 10. X is 9. So then I go back. What were these angles? 3 times 9 and 7 times 9. The actual angles were 27 and 63. You see how that works?
How